Hello and welcome everybody to Booze Hour Cloud Edition today. Today we've got on a repeat guest, Sam Gabrail from HashiCorp, and we're going to go over part 2 of his series. So if you scroll back through the YouTube archives of Daryl and Boo, youtube.com/Daryl and Boo, you will have actually seen Sam from probably 6 weeks ago, and he did part 1 of his series, which was going over the HashiCorp tools and his journey in learning those tools as he got onboarded at HashiCorp. So the first one was Terraform and using that for infrastructure as code. And then today we'll go over part 2, which is using HashiCorp Vault. So he will go over, I've checked out his article before. He goes over, a basic implementation of that to get used to the product. So before we bring him on, I have a couple things to go over. First of all, this is the last few stickers here. So I've been sending these out all across North America, which has been cool so far. Nobody overseas has asked for them, although I can only send them to North America. Anyways. A couple other things. Oh, and besides the stickers, I got something else coming up after these stickers are gone as well. So let's get through these last few stickers, and then there will be a big reveal for what the next little item will be. A couple other things. If you are watching this via LinkedIn right now, and if you're not following me already, you can hit the follow button on my profile. I go live about once or twice a week. With topics around technology, and we have another live stream that I do occasionally, not every single week, but it is more of what I call community edition, and that's usually featuring somebody who's from the Vancouver IT community, but not always IT related as well, just somebody from community that can share a positive message. So a couple of things to look out for in there. But if you're watching from YouTube right now, or if you're not even watching from YouTube, you're watching from LinkedIn, head over to YouTube, hit subscribe, which is the button below here, and then you'll see the content as it gets released on YouTube, because some of the content doesn't actually make it over to LinkedIn. And that is going to be especially important for the next few weeks. So I have some PTO coming up, not all at once, but just kind of spread out over the next couple of weeks. And so won't be, live as much, but I have some recorded content that I am coming up with that I will release during my time away. So nobody has to miss out on content while I'm away. So a couple of things there. Also, there is a newsletter. So if you head over to darylandboo.com, you can just sign up with name, email address, and we will send you a weekly technical newsletter with all things F5, IT industry related, Vancouver related type stuff. So check that out if you can. Also on darylandboo.com, there is an event calendar as well, so you can preview upcoming live streams. So you can do that by checking out YouTube. I usually load the upcoming live streams as soon as I have them kind of finalized, and I have the thumbnail and whatnot ready for them. But you can also check out the event calendar. And also there's this in a podcast format as well. So Apple, Google, and Spotify, you can download this content if you want to listen to it. Now, some of this content, like what Sam's content is, like some of it will be walking through some of the article that he's written. So, some of the stuff makes more sense to watch, but I do always make it available via audio format as well. And otherwise, if you are watching on YouTube or on LinkedIn right now, just please say hello. Let us know where you're watching from. If you have any questions around HashiCorp, around F5, and around anything IT related, around me, please do reach out and say hello on there, and I can pull up your comment on the live stream as well. All right, so that's all the stuff I have to go over. Now I will bring on our guest, Sam. Hey, Sam, how's it going?
Hey, Boo. Good. How are you?
I am doing well, thanks. How's things out in Toronto? We're going through a heat wave out here. Wondering if you guys are feeling the same.
Yeah, well, actually, we got a thunderstorm yesterday, and
okay.
My 2-year-old and my 4-year-old were amazed seeing lightning and thunder, and had to explain what that means and how it works. So
yeah. Oh wow.
Yeah.
My are they both boys?
Yeah, 2 boys.
Okay. Yeah, my boys think thunder and lightning are cool. My daughter gets scared sometimes, so we have to balance who's who's exposed to it or who we hide under the blanket.
Yeah, yeah.
Yeah. So you are, I believe, our first repeat guest. I believe you were actually our first outside guest on Cloud Edition, and this just kind of speaks to the partnership that we have with HashiCorp. If anybody's watching some of the content that's out there being produced by F5, a lot of that content is not. I shouldn't say a lot of that content. A lot of that content is F5 focused, but partnership focused. HashiCorp is one of the ones that we have been doing a lot of joint presentations with, because it just makes sense for infrastructure as code, and that's the direction that lots of organizations are heading, and that's a lot of questions that we field from customers as well, like how do I build this into cloud? And it becomes really important to look at building out as infrastructure as code. So this partnership makes sense, and so I'm really glad that we're able to do live streams like this with you.
Absolutely. Thanks for having me.
Yeah. So this is part 2 of your 4-part series. Now, first one, we went through Terraform, infrastructure as code, and now we're going through Vault. Right?
Yep, that's right.
Cool. So I'll let you drive from here. I know you have content that you can walk us through, and this is all about your journey through building out a Vault environment.
Yeah, exactly. So basically, when I joined HashiCorp back in January of this year, the first thing I wanted to do is figure out what are these tools that HashiCorp offers and why actually use them to begin with. So I thought, okay, well, I'll put myself in the shoes of a developer and figure out what I can do without HashiCorp tools, and then how I would use the HashiCorp tools and what kind of problems they solve. So I started off with Terraform, as you mentioned, Boo, and figured out, okay, well, first of all, I need to build an environment, and that's where Terraform comes in, builds the environment for my application. And just as a reminder, it's a web blog app, a very simple application with a database backend. It's a MongoDB backend, and it's just a Python Flask application. So that was part 1. And now that I have the environment up and ready, now part 2 is, okay, well, I need to provide secrets or credentials to the database. So my Python app needs to talk to the database. So it needs credentials to connect to the database. So how do you do that? How do you do that without Vault? And then how do you do it with Vault? And then there's more. We'll find out as we go through the article.
Cool.
So let me share my screen here. Let me know if you can see it, Boo.
Looks good.
Okay, cool. All right, so this is part 2, as we mentioned, and we just went over the overview really quickly. But basically, I'm going to walk through this and then just go through a quick demo just to show you what the app looks like and how Vault works and how Vault delivers the secrets. So in a typical journey, folks will not have Vault, and a developer will typically have a configuration file where they're going to dump the credentials to the database, or maybe use environment variables to access the database. Then once I start looking at Vault, we always, call this the crawl, walk, run journey for an organization adopting Vault. And the crawl phase is really looking at how can we centralize secrets. So those secrets, it could be API keys, they could be usernames and passwords, can really be anything that's deemed sensitive, right? And those, when you start off, you want to centralize them all in one place, because some organizations, some people have secrets all over the place. They could be in spreadsheets, they could live in GitHub repos, and there could be multiple users or multiple developers that have access to those repos. So you don't really know who gets access to what credentials at what time, and so on. So the first step is really centralize all your secrets in one place. And the easiest is to use what we call the key value secrets engine. And that's a simple key value pair where you put your username and password, for example. The next phase is what we call Vault Dynamic Secrets. This is moving from just those static secrets, which you can rotate, but you gotta rotate them manually, or maybe write a script to rotate them. Whereas the dynamic secrets, you're actually getting a username and a password from the database that you're using, because this is a dynamic database secrets that we'll see in this article, but you're going to get those secrets dynamically upon request. And then they get generated, and then there's a time to live, and then they get removed. And finally, we see a lot of folks using our encryption as a service within Vault. So an API call, send the plain text, get back the ciphertext. So for this article, you can quickly see the code here, and there's also a video that I put together that goes through all of this and shows a demo as well. The prerequisites, just like the first part one, is I'm running this in GCP, the free tier. You'd probably want to use Terraform Cloud, and also GitLab is what I use for the VCS and CI/CD. So really quickly, let's take a look at the deployment. So upon a commit and a push from my VCS from GitLab, CI/CD kicks in. It deploys the Python app, and I have the MongoDB pod inside of Kubernetes deployed through Helm. So every time I make a change, the application gets redeployed. So pretty simple. This is what the actual blog looks like, but we'll take a deeper look in the demo at the end. And the Vault configuration itself, if you want to learn more about Vault, there are really two steps with Vault. The first step is you need to authenticate with Vault, meaning that as a client, whether I'm a human or an application, I need to present my ID to Vault. So whether that's, think of it as a passport or a birth certificate or a driver's license, something to say who I am. And there are multiple authentication methods. Some of them are on the screen here. You can see you can use Okta, Radius, LDAP, or Active Directory. You can use some of the IAMs from the clouds, whether AWS, Azure, Google, and you can use Kubernetes as well. In my case here, I'm using Kubernetes to authenticate, since the app is actually deployed inside of Kubernetes. Once you're authenticated into Vault, through a policy, you're authorized to do certain things and retrieve certain secrets. And the secrets that we have here, we call them secrets engines. So as I mentioned, there's the key value pair, there's the dynamic database secrets that we'll also see, and then the transit secret is the encryption as a service that we'll also see. Users also find the PKI certificates a very useful secrets engine. Many folks use it as well. Okay, so yeah, as I mentioned, you authenticate and then you retrieve those secrets. Now, just a quick note here. In the last blog post, we talked about Terraform and Terraform to deploy the environment. You can do more with Terraform. In this case, I'm using Terraform's Vault provider to configure Vault using Terraform. So in that same repo that I'm using to deploy Vault through Terraform, I'm also using Terraform to create configuration inside of Vault. This is one of the best practices to do configurations for Vault. It's saved in your version control system. You know exactly what happens. It's controlled through Terraform. So a very convenient way of doing it. Of course, there are other ways as well. But as long as you make sure that you're saving that configuration in your version control system so people know what's been configured in Vault, that's very, very key. All right, so let's take a look at those 4 phases that we're talking about. First phase is what do you do if you don't have Vault to begin with? And as I mentioned, typically folks will have a configuration file. In this case, I had my .env file where I had my secrets that lived there, and the application reads those secrets from that file, and it goes ahead and makes a connection to Mongo database and does its work. So the first phase with Vault is the key value store or key value secrets engine. And in this case, the way it works really quickly is you have a namespace inside of Kubernetes that I have here. I call it Vault, and it has 2 pods. The actual Vault server lives here, and another pod called the Vault Agent Injector. And if you're familiar with Kubernetes, this is a mutating webhook, which basically means that in my main namespace, which is the weblog namespace, I have a pod, which is the Python app, and I have another pod that's the MongoDB pod. So that this injector, upon annotating the deployment of the Python app, I say, hey, I want to inject a sidecar, a Vault agent sidecar that's going to do a few things for me. And once I annotate that pod or that deployment, then the agent injector is going to inject sidecar when the container comes up, when the pod comes up, rather. So now you have two containers inside this pod, the Python one, the main one, and also a Vault agent sidecar. And what it does a few things. First, it authenticates into the Vault server, and again, uses Kubernetes authentication backend using a service account. It's tied to a namespace, tied to a service account. And at this point, now that you're authenticated into Vault, it does auto authentication as well. So you can have a time to live for the token, and then it rotates it and then re-authenticates into Vault. And the second thing it can do for you is it can actually inject secrets in a secret mount inside the pod so that my Python app can retrieve those secrets to use to connect to MongoDB. And that's exactly what we do here. So my app actually doesn't need to know anything about Vault. So it's Vault unaware. And the Vault agent just grabs the secrets from the Vault server and puts it in this mount here, as you can see. And all my app needs to know is the location of this file inside the file system, so it can read the secrets from there. So it's pretty simple. It's just similar to what I used to do with the .env file. Now you just got to read it from a different path. And that's it. Once I have the credentials, I can now connect to the Mongo database, and the application runs fine.
That's it. I mean, the advantage there too is the app team doesn't necessarily have to talk to the security team as if the security team is managing the Vault side of
Yeah,
things, right?
exactly. Yeah, I mean, it really depends on the organization. It could be the security team that manages the Vault. It could give some developer teams certain privileges to deploy certain secrets into certain namespaces. Even within Vault, Vault has the ability to do namespaces, so you can segregate vaults into mini vaults. Or you can specify certain paths for certain teams. Yeah, exactly to your point, Boo. There's a lot of flexibility there.
Very cool.
Yeah. So what I like about this is I don't have to have any knowledge as a developer of really Vault, and the secrets just get injected to this location. And this is very similar to if you're not running Kubernetes, you can run this on a regular VM, and your agent will just be a process running on that VM, supplying the secrets for you at a path that you can pick it up from. Cool. So what the annotations look like, you can see here, this is the deployment for the Python app. And some of the annotations you can see here, we're saying inject true, giving some limits. And at the bottom here, you can see that we have a templating engine that is grabbing the secret from this path in Vault. So Vault has the concept of paths. Everything lives in a path. Every secret lives in a certain path. So I'm calling on this particular secret from this path, and I'm creating this DB user and DB password elements that will live in the file that gets picked up by the app, and they get filled up with the username and password credentials that live in Vault. So that's phase 2. Phase 3 takes this a step further, and instead of doing things statically, as we saw with the key value pair, now we can do things dynamically. So, and I'm really, really excited about this concept of dynamic secrets because it does a couple of things. You don't have to worry about rotating those secrets manually now. You can specify a time to live, and that secret will be valid for that specific time period. So as you can see in the demo, I specify the time to live of 10 seconds just to speed things up for the demo. But you can really say, hey, I want these credentials to live only for a day. And after a day, those credentials get removed and you get a new set of credentials. The other neat thing is that you get a unique username and password for every call that you make to Vault. So let's say you have 50 web servers talking to one backend database. Those 50 web servers, each one of them will get its unique credentials to the database. So in the case of a compromise, let's say web server 10 got compromised, then that particular server, you can revoke its credentials and it's not going to affect your application. You won't have any downtime. Only that particular server will need to rotate the credentials for, but the rest of the other 49 servers are good to go. So that is also a very neat concept as well. So let's go through this really quick. Same idea. You have your Vault agent injector, injects a sidecar. This time, the sidecar provides a Vault token at a specific path. The Python app reads the Vault token and makes an API call to generate the dynamic secret from Vault, which in turn, Vault actually connects to the Mongo database and creates credentials inside of MongoDB upon this call from the API. So now we have a username and password created in MongoDB by Vault, and that gets passed back to my application, my Python app, that then it connects to MongoDB, and away we go. Now, this concept of dynamic secrets, the way I've done it here in this app is making the app now Vault aware. So now I've changed the code a little bit to make a call to Vault, and then from there on, make a call to MongoDB. But also, because I'm destroying the secret every 10 seconds, I have some logic inside the app to say, hey, if I can't authenticate into the database for some reason, then reinitiate the database credentials or the database connection, if you will. You don't have to do this way. You could also, similar to what we saw earlier, make the app not Vault aware, and at that point, even the dynamic secrets can get put inside the pod, so you can read it from there.
So does this work for any app, or is there a specific list of apps like MongoDB that this is certified to work with?
Yeah, good question. We have a number of databases that we work with. So we got the major ones: Oracle, Microsoft SQL, MySQL, Postgres. A bunch of them. Mongo, of course. So we have them all in the documentation. Yeah.
Very cool.
Cool. Okay, so let's look at the fourth phase, which really is doing encryption in the app now. Remember, this is a blogging app, so I thought, it might be cool to demonstrate this by actually encrypting all the content of the posts. Maybe they're sensitive for some reason, and I don't want people to see them inside the database. So this is how we're doing it. The app makes an API call to Vault with the plain text that I want to encrypt, and then Vault responds back with a ciphertext. And that's it. The app takes then the ciphertext and writes them into the Mongo database tables. All you need to do inside of Vault is specify the encryption key that you're going to use. And then with the API call, you send the plain text plus that name of the encryption key that you're going to use. Vault handles all the cryptography for me. I don't have to worry about getting a library embedded, a Python library for cryptography, and managing the lifecycle of that. I don't have to worry about the key management, the encryption key management itself, which actually is quite a headache to manage by myself. So Vault also takes care of that. I can revoke that encryption key. I can create a new one and rewrap the old one. So all of that gets handled by Vault for me, which is very, very handy. And then the reverse direction also works, of course. So the app now wants to present the posts to the user. So it does a call to the Mongo database, grabs a ciphertext, sends it over, makes an API call with a ciphertext and the same key used for encryption to Vault, and Vault responds back with the plain text. Then I can present that plain text to the user. And that's pretty much it. So let's do a quick demo here. So here's the actual app. It's this very simple, basic blog. You can see here, my kids love cars and dinosaurs, so I decided to have two blogs, one for cars, one for dinosaurs. And you just click on one of those. You can create a new post, you can create a new blog, and so on. You can log in, log out. But really, the key thing here is to see what happens in the backend. So let me pull up my terminal window. Let's make this a bit smaller. Okay. And what I'm going to show is the dynamic secrets feature. So what I'll do is I'm going to just interact with the app. So I just clicked on blogs, right? So if you can see here at the bottom, the server responded back with a username, this long username here, all the way to here, which is very unique to that particular call from that application, and the unique password as well, right? Now, 10 seconds have passed. So if I click on anything here, let's see, you can see if I scroll down. Now, MongoDB authentication failed due to credentials expiring, rotating the credentials now. I got a new the Vault token, as you can see, but then here's a new set of username and passwords that got created for me. So you can see it's different from the username that's up here, and the password is different from the password that's down here. And that's the idea, that dynamically these credentials get rotated for me. So the attack vector is much, much smaller. In this case, it's only 10 seconds. So that's the first part. The second part I want to show is the actual encryption itself. And this is a quick application called MongoDB Compass, which just shows me things inside of my MongoDB. If you notice, I've got two tables here, or two collections, or two databases actually. And inside here, I have the posts collection. And as you can see, the title here is in plain text, but the actual content is encrypted, as you can see here. So it's just a big blob of gibberish. You can see Vault v1. That means that I'm using the version 1 of the key to encrypt this. If I update the key and use a different encryption key, you'll see this update to version 2 and so on. If I look at the post collection in the weblog database not using encryption, as you can see, of course, everything here is in plain text. So the idea here of encrypting is that maybe you don't want your database admins to have access to some sensitive information. The other obvious one, of course, if the database gets hacked for some reason, then your sensitive information is encrypted right there. Cool. And that's pretty much what I have to show you guys today.
That is awesome. And again, this is stuff that you've published to GitHub as well, so that people can try it out on their own?
Yes. So at the top of the article here, you should be able to see under the TLDR, where is it? Right here. Yeah, you'll see two repos, one for the actual Terraform configuration of Vault and one for the actual weblog app itself.
Very cool.
Yep.
Yeah, this is great, Sam. Hopefully that gives everybody a really quick start to get going with Vault. I know in labs at F5 that we produce, we try to incorporate vaults for secrets management as well. That is, the walk and run there were things that I hadn't seen actually before with Vault. I'm only actually familiar with the very basic stuff. So that's great that we even were able to get through that today and check that out. So Excellent. Really cool. Thanks for coming on, Sam. I think we'll be able to book like the part 3 in a few weeks as well and have you back on. And then you'll be the first three-peat guest as well. So sure, excited to get you like a championship belt or something for that. Cool. All right, folks. Again, I am on some PTO kind of scattered through the next few weeks, so you won't see as many live streams from me, although I do already have a couple that are booked, but they'll probably just be like one a week for the next couple weeks here with some recorded content mixed in. So look for that, subscribe to the YouTube, and yeah, thanks a lot, Sam, for coming on.
Thank you.
Bye for now. Thanks for checking this out today. If you're watching via YouTube right now, go ahead and click subscribe down below. Also click the bell for notifications. That way you will find out when we are dropping a new video or when we're going live. Also, there's darylamboo.com. If you head over to that, leave your name and email address, we will drop a weekly technical newsletter in your inbox every Monday. Also, this is available via podcast, Apple, Google, Spotify. Head over to one of those, hit subscribe, and you'll be able to listen to us in the car on your commute or during a walk or a run. Thank you very much, and we will see you next time.